Alright guys, here's the bell work. I'm gone today, so you guys got a sub, but um, should be doing this on the pink worksheet. So hopefully you guys have picked one up when you guys walked in, and get started on this problem. I'm going to give you 1 minute to do it, okay? Alright, this is the answer I got, so we can form a proportion, of course, on this. You got 17 trees to 2,000 pounds, and so you got 5,000 pounds over here, so how many trees? And yeah, we'll just use fish method on this one like this. So you do 5,000 times the 17 divided by 2,000, right? And yeah, I would just put that in the calculator. And for me, when I did it, I got 42.5, which is pretty close to 43. That's why we put about 43. I mean, how do you save half a tree, I guess? Well, burn half of it, chop half of it down. It's probably killed the whole thing. So we just rounded it up to 43. Alright, this is our objective. Go ahead and take a minute and write this down. I can write equations for proportional relationships. So you guys have already had some experience doing this, so hopefully this time around it's not so bad. Alright, that brings us to our first problem right here. Peter is renting wave runners for a company party. Each wave runner holds 3 people. Complete the table and graph to show this relationship. Write an equation that shows the relationship between the number of people P that can ride and the number of wave runners W. Then we'll use our equation to figure out how many people can ride if Peter rents 20 wave runners. And I know some of you guys can do that in your head, but we're still going to go over it, all right? So first of all, it's 3 people per wave runner. So if he rents 0 wave runners, sure enough, he can let 0 people ride. But if he rents one wave runner, then yeah, 3 people can ride on that. So 2 wave runners, well, you'd have 2 groups of 3, which would be 6 people on the 2 wave runners. So of course, how many people or how many wave runners would you need to rent? For 9 people, well, it's 3 people per wave runner, so I'd say 9 divided by 3, which is 3 wave runners right there. Now it jumps right here, so it's suddenly 8 wave runners, and we know it's 3 people per wave runner, so 8 times 3 is 24. So the last part right here is just to help us to figure out kind of how the equation is going to work. Well, what do we do to all these values? We just multiplied them by 3 to figure out the corresponding number of people that we needed. Now, of course, you'd say, well, the 9, you divided it by 3. That's correct, because in that case, we're going from people to wave runners. But this one's showing wave runners, right? So how many people can ride if you rent any number of wave runners, specifically W number of wave runners? Well, you just take that number and multiply it by 3, whatever it is, and then you'd figure out how many people could ride on the wave runners. So to put this on a graph, right? Well, we know 0 wave runners would let 0 people ride. 1 wave runner, though, is going to go as high as 3 people right there. Well, then we get 2 wave runners, which would be as high as, looks like 6 people. And 3 wave runners will go as high as 9. 4 wave runners will accompany 12 people, and then 5 wave runners up to 15. So we don't need the rest of those values, but this is a pretty good indication of how this will work. Now you may ask, well, shouldn't we connect the points? And the answer to that is no, because this is discrete information right here, which means that we do not connect the points. Here's what let me go a little bit further into that. Well, if you connected the points, you'd have a point, about right there, okay? Well, this would indicate that you could have half a wave runner and also half a person. Well, you can't have half a wave runner. You can have a smaller one, but it's still a wave runner. And you can't have half a person, because even, people without legs or something like that, it's still a person, okay? So these values are not actually possible in a graph, so we are not able to connect the points on the graph. So that's the graph in the table. Well, it says write an equation for this. Well, that's pretty much what this 3W is for, right? The number of people, P, that can ride is going to be the number of wave runners, but just multiply that by 3. P equals 3W. Now, in one of the previous lessons, we talked about this 3. It's called the constant of proportionality. It's the coefficient of W because it's being multiplied by it, okay? Now use your equation to determine how many people can ride if Peter rents 20 wave runners. Well, we'll do this one in a different color here. Well, it's the number of people is going to equal 3 times the number of wave runners, right? Well, they told us that the number of wave runners is 20 in this case. And 3 times 20 would mean that it's going to accommodate 60 people. I can't quite fit that in there, so PPL. 60 people you could have on wave runners if you rented 20 of the wave runners. Alright, Bubba's Body Shop charges $25 per hour to fix a car. Complete the table and graph to represent this situation. Then we'll also write an equation that models the relationship between the cost C Bubba charges to fix your car based on the number of hours T he works on it. Where do you see the unit rate in the equation? We'll talk about that. Use your equation to determine how much Bubba would charge if it takes him 12 hours to fix your car. And use your equation to determine the number of hours Bubba worked on your car if he charged you $175, okay? Well, it says that it's just $25 an hour straight across, right? So for 0 hours, bam, he's not going to charge you anything right there, right? Now for 1 hour, though, yeah, that's where that $25 comes in. So 2 hours, bam, it's another $25, so total's $50 now. And then for 3 hours, that would be the $75, right? Because we know it's $25 per hour, so you could say 75 divided by 25, which is 3. Well, then it jumps again up to 8 hours. Well, we know it's $25 per hour, so just multiply the 8 by 25 to get $200. Now, we're not labeling these, by the way, because it's already labeled up here in dollars. Finally, we end up with the T, right? Well, how much would it cost based on T number of hours? He's going to multiply it by 25. Okay? And that would tell you how much it would cost in dollars. Next up, the graph. Well, one thing we need to do on this graph before we do any graphing is to label the axes. All right, so the y-axis, remember this is always going to show us in the table, by the way. The y-axis is dependent on the x-axis. And the number of dollars definitely depends on the number of hours he works on your car. So over here, I'm just going to put cost. That's the label for the y-axis. And the x-axis is independent. That's just the number of hours. So that's the labels. Now what we need is a scale on this graph. And I always like to start with 0, and you know what? I'm just going to make each of these lines go up by 1. So there's 5, 6, 7, 8, 9, 10. So we can see up to 10 hours. In fact, we're going to do the same thing on the cost. It's just that the scale is going to be a little different. Because I know, and this is just to make the graph look really nice, since Bubba's charging $25 per hour, all I'm going to do on this one is make the lines go up by 25. All right, so every fourth line is going to show 100, 25, 25, 25, 200, 25. So it goes as high as 250. It's $25 each line for the y-axis. And sure enough, for $0, yeah, 0 hours rather, $0, 1 hour, $25, 2 hours, 50, 3 hours, 75, and this would just continue to go up in this manner. We do have the 8th point in this. The 8th hour was right there, right? And then we have the first 3 that it showed as well. All 4, I guess. There we go. Well, would we connect these points? And that's a good question to ask. Well, yeah, because you can start paying partial amounts in cost. And he could work for just part amount of the dollars as well. So let's just connect this line, these points, with this line right here. And while that's not my straightest line I've ever drawn, well, I guess none of these really are. It still works, okay? As long as we can see those points, we can tell how much he would charge based on the cost. So next up, it wants us to write an equation for it. And again, that's kind of what this box right here is for. We know that the total cost Bubba is going to charge is $25 multiplied by the number of hours. So if you just wrote this as 25t, that's fine as well. And where do you see the unit rate in the equation? That's a good question. Well, the unit rate, we know, is the 25, right? So we know it's $25 per hour. And so that is what we call the coefficient of, in this case, t. I'll move that down a little bit. So the coefficient of t, which is 25, that is the unit rate, which we'll get pretty used to seeing right there. Again, it could be called a constant of proportionality, which is still the coefficient of t in the equation. So now use your equation to determine how much Bubba would charge if it takes him 12 hours to fix your car. All right, well, it's the cost is going to be $25 per hour, but now it's for 12 hours there, right? When you multiply this in there, it'd be $300. But then it says use your equation to determine the number of hours Bubba worked on the car if he charged you $175. Well, now the 175 is right here, which is going to equal, $25 times the amount of time. So to solve this one, all we're going to do is divide both of these by 25. All right, so the amount of time that Bubba worked on your car, in this case, would have been 7 hours. So he'll have to work on your car for 7 hours in order to charge you $175. And I believe we completed that problem right there. It's pretty good. All right, let's go through this one. Carmen is making Rice Krispie treats for an upcoming bake sale. Carmen uses 6 cups of crispy rice for 36 jumbo marshmallows. Complete the table and graph to show this relationship. Be sure to label the axes on your graph, which we actually have already. We see that the marshmallows are the x-axis and the crispy rice is the y-axis. That's okay. We still need to label those, and if you're doing it by hand, though, you'd have to label it. And the scale is already given for us as well, which is pretty generous. Well, here's the information they gave us. It's 6 cups of crispy rice for 36 jumbo marshmallows. So right here, I don't see that on there, but it's scalable, okay? So what I mean by that is 6 cups of crispy rice. Well, it would show us a ratio like this, right? So 36 marshmallows for 6 cups of crispy rice, okay? Now in the table, all that's missing are the crispy rice cups. So like I said, this is scalable, so I could say, you know what, I know 36 and 6 are divisible by 6, right? So that'd be 6 marshmallows for 1 cup of crispy rice, which is on the table. I see 6 number of marshmallows. That would be 1 cup of crispy rice right there, okay? And of course, without any marshmallows, you're not going to have any cups of crispy rice on this. So from here, this ratio right here, 6 marshmallows to 1 cup of crispy rice, is scalable as well. So you see 6 times 2 is 12, so that'd be 2 cups of crispy rice. 6 times 5 is the 30, that's the 30 marshmallows, so 5 times the 1 cup of crispy rice, that's 5 cups right there. Well, what do you got to multiply 6 by to get 48? That's 8, so that'd be 8 cups of crispy rice. Now it reverses though, right? Now right here, to get from 6 to 1, you'd have to take 6 and divide it by 6 to get 1. So what do you got to do to the 1 right here? You got to divide it by 6, and that's 1/6 of a cup of crispy rice for 1 marshmallow. So marshmallows, what are you going to do to the marshmallows in order to figure out how many cups of crispy rice? Well, it shows through each of these, right? You'd say 6, and I'd say multiplied by 1/6. Some of you guys would say, well, divide it by 6, and it works. Okay, but it's going to show up the same way. You can multiply by 1/6, or you can divide by 6 to get these. Now, what do we do on this one? It's 1/6 cup of crispy rice for 1 marshmallow. So I would rather see it like this, just in terms of an expression form. Okay, so 1/6 times the number of marshmallows will tell us how many marshmallows, or how many cups of crispy rice, rather, that we need for this relationship. So how does that affect the table? Well, 6 marshmallows, we know that's going to take 1 cup right there. Right there, right? 6 cups. 6 marshmallows for 1 cup. Well, then also 12 marshmallows for 2 cups. So, not that it shows on our table, but 18 marshmallows would be for 3 cups. And so 24 would be for 4 cups, right there. And then finally 30 marshmallows for 5 cups. So this shows pretty well, and of course we got 0 marshmallows for 0 cups. And you could say, well, we would connect these points, right? Well, yeah, sure, as long as you consider you could have half a marshmallow, okay? So as long as you're thinking in those terms, that's fine if you connect the dots. I'm not going to, because I wouldn't want to think about, well, I'm going to start cutting up marshmallows, which are kind of squishy and difficult to cut. So I am not going to connect these, even though you could have half a marshmallow. So sometimes it's more about, I guess, the logic. Like, would you logically cut marshmallows in half? Probably not. Like, I'd probably just start putting full marshmallows in. I like extra marshmallows in my crispy rice, okay? Rice Krispies. So write an equation that shows the relationship between the number of marshmallows, M, and the number of cups of crispy rice, R, needed to make crispy Rice Krispie treats. Well, we'll use the same letters they told us. So R is for the cups of crispy rice, R, and this is going to equal, we know we're going to have a certain number of marshmallows, but how many cups do we need in relationship to the marshmallows? You just take the marshmallows and multiply it by 6. Now that works, but if you were like, again, going back to this stuff, if you said, well, divide by 6, right? Well, then the cups of crispy rice would be the marshmallows, and then just divide it by 6. And I prefer to show that as a fraction, but you don't have to. So what is the unit rate? And this is where we can run into some problems on this one. Well, there's 2 unit rates, right? Because we see a 1 value with the crispy rice there, but also a 1 value with the marshmallows. So you could say it's a 1 marshmallow to a 1/6 cup of crispy rice, but you could also say that it was 6 marshmallows to 1 cup of crispy rice. And it depends on how you're using your recipe, which would determine which of these is the most useful. Okay, and again, if you wrote it as a fraction, that's fine, you know. Use the slash. Maybe I did that the wrong way. It doesn't really matter. But, yeah, that would be the unit rate. 1 marshmallow to 1/6 cup of crispy rice, or 6 marshmallows to 1 cup of crispy rice. All right, so with that much, we should be able to figure out how to write these equations, all right? Now, just so you understand, all the equations are going to take the form y equals mx. Now m is the rate of change. Why did they use m? That's for a different unit. Actually, I don't know, but they use m. Okay, m tells us the rate of change. So once you figure out the rate of change, and this is specifically related to the x, right? So whatever you're multiplying the x's by, that's how you get your y. All right, so just like we saw with the crispy rice, the marshmallows multiplied by 1/6 tells us how many cups of crispy rice we need. Now some of these are pretty easy to see, right? Like I can see 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12. Well, since I see that all I'm doing is taking the x value, I'm multiplying it by 4, and that tells me the y value. That's the equation. When we see the values are smaller, just remember that it has to be division on this, okay? So I know it's 40 divided by something is 8, but what? 40 divided by 5 is 8, and it should be consistent for these proportional type relationships. As soon as it's not proportional, then it won't work, which is why we're focusing on writing the equations for proportional relationships. So I see all I did with the x is I took it, I divided it by 5, and that's my y value. Okay? And in fact, it's going to work the same way on this next one. But I'm going to use multiplication on this one. 1 times 1/3 is 1/3, which means 2 times 1/3 is 2/3. And 3 times 1/3 is 1. That is true. So what are we doing? I'm taking 1/3, I'm multiplying it by x to get my y value. Well, what's the difference between putting y on the right side of the equal sign and on the left? Just depends on how you want to write it. So this purple one, for example, if you had written it as y equals x divided by 5, that would be fine. And the division sign as well. If you wrote it as y equals x over 5, that's fine. Or even y equals 1/5 x. That is okay as well. So take a minute and see if you can figure out what the equations are for these three, and then we'll go over them here in 1 minute, all right? 1 minute, go. All right, that seemed like a pretty good minute right there. So what are we going to do on these ones? And hopefully you guys can see, even if the first one doesn't really make sense like it does in this table, I can see the relationship between 1 and 6 pretty quick, right? Well, x value, what do I do to it to make a y? Well, multiply it by 6. Does it work for the rest of them? It sure does. 1/2 times 6 is 3. 3/2 times 6 does equal 9. So what did we do? We took the x value, we multiplied it by 6, and that is our y value. And this next one, again, I would look at a value I know for sure, which is really between the 1 and 2, right? Well, 1 times 2 is 2. That's pretty quick. Notice we're not doing any addition and subtraction in these tables. It's always multiplication or division, which is why that equation always takes this form, y equals mx. So does it work for the rest of them? It sure does. Okay, so what do? We took 2, we multiplied it by x, and that's our y value. Bam. Next up, again, I see a very good, very quick relationship between 1 and -3. Yeah, you're just going to take the one and multiply. Yes, it's by a negative, but that's not a problem. You can multiply all of these by a negative, and that's how you get these answers. Okay, so sometimes it is about finding one that you are more comfortable with, just like I've done right there. So y, what does it equal? Well, it looks like we're taking negative 3 and multiplying it by the x. And there are 3 equations for these 3 tables. All right, take another minute and see if you can write the equation for these two. Again, it needs to take this form: y equals m multiplied by x. All right, this next one is a little tricky, right? Just because, you got to increase the number, but it's not so obvious what we're going to increase it by, right? In fact, you couldn't work it backwards and say, well, 1 times 0.75, that's pretty good. Okay, the problem is that when you take your x and you'd say, well, you're going to divide it by 0.75, it's just not very formal to put decimals in your fractions like that. So, what are we going to do? Here's what I would do, is I would write this as 1 over 0.75, which is, it's correct, it just isn't proper to do it that way. So 1 divided by 0.75 in my calculator. It gives me this fraction, but not fraction, but it gives me the decimal, 1.3 repeating. I just don't want the decimal, so I push the double arrow button on the calculator, and it shows me that it's 4/3. So that means that if I multiply x by 4/3, it should be good. Let's try it on the 3.75. If I multiply it by 4/3, does it give me 5? Let's try it. 3.75 times 4/3. Yes, it does equal 5, so now I know that is the equation for this table. But then on this next one, it's kind of the same idea. Again, maybe it's not so obvious though. So, again, maybe it's good to just make a table on this one. And you say, well, if x were 1, what would the y value be? Well, how do you get 1? I'd be looking at the 10. I'd say, well, you divide 10 by 10, right? So 6 divided by 10, which would simplify into 3/5. Well, that's pretty easy to tell. What do you multiply 1 by to get 3/5? You'd multiply it by 3/5. Okay, well, that means it has to work for all these. So 10 times 3/5 is 6. Let's put it in the calculator. 10 times 3/5 is 6. And so 90 also times 3/5 needs to equal 6. Let's try it. 90 times 3/5. Not 6, but 54. And it works. Okay, so we're just going to take the x value, multiply it by 3/5, and that's our y value. And that would be the equation for any of the values that correspond with these in this table. This equation works. Now let's look at these a little different, because just like we showed before, m is really the rate of change on this. And if you guys remember how to find the rate of change in the tables, this should hopefully make sense. And it would work on the graphs as well. As long as you can find the rate of change, then you can replace the m in your equation and you're done. Okay, so what I'd be looking to do is figure out the changes in the y's and the x's respectively. So right here, the change in the y, from 1 to 5, it went up 4. So you went 1 plus 4 there. And then 0.75, what do you got to do to make it a 3.75? You'd have to add. And when we're looking at the changes, we're looking specifically at addition or subtraction. Well, as a rate, that's 4 y's to 3 x's. And if you remember, that was the equation we found. Y equals 4/3 x. Okay, and it does work in this other one. From 54 to 6, you'd have to go down. Oh, what the heck is that? 48. There we go. I used the calculator to find that difference. Well, that's the change in the y's, but what about the change in the x's? You'd have to go down 80 on this one. So as a ratio, it's negative 48 to negative 80, right? But we want this as a fraction, so you just type this into your calculator. Negative 48 over 80 And, well, the fraction that I get out of that, my calculator give it to me 3/5, which is exactly the fraction that we found before. Again, we're just, right, when you got y equals mx, and you find the rate of change like that, you just replace the m with that rate of change, which in this case is 3/5. So it works both ways. The way we did it before is specifically we can use it, do it that way because these are proportional relationships. Once they're not proportional relationships, we have to use this method. So keep that in mind moving forward. And again, just for a table like this one, right? When you have an x is 1 right here, like in this part of the table, all you're going to do is multiply it by whatever the y value is to make it that y value. So multiply it by -1/2. But again, just to ensure that it works, multiply it in the other boxes to make sure that works. And sure enough, -1 times -1/2 would give you that +1/2 right here. So you're going to take your x, you're going to multiply it by -1/2, and that is your y value. So now take a minute and just see if you can figure out the missing values in these tables, okay? We'll give you 1 minute. Try that out. Go. All right, let's see what we get on this one. All right, so on this first box right here, we're gonna figure out the y value, right? Well, it gave us the equation y equals 3x, and they just gave us the x value right there is 6 right here. So we'll just replace the x with 6 and solve. 3 times 6 is 18. So y is 18 when x is 6. So the next up, still going to use the equation like it told us to do. Not that you really have to do it that way, but it's just saying that the y is 24 in this case. So yeah, we just replace the y with 24. So 3 times what is 24? Hopefully you know the answer to that is 8. If not, then you could use principles of equality to solve this, and you'd see that x is 8 when y is 24. And it's important to remember the two values correspond to each other. How many values are proportional in this type of relationship? There's an infinite number, as it turns out. So keep that in mind moving forward. If we wanted to, we could find an infinite number of values that correspond in the way that this equation is showing. That's going to be important in a later unit. On this next one, it says y equals 1/2 x, right? So we're going to take the x, multiply it by 1/2, and that's our y value. So 20 times 1/2, 10. Well, what do you do with the y values when it's y equals 1/2 x? Well, again, this was moving this way, and this one we want to move this way. So just multiply it by 2. It's the inverse of whatever we have right there. You could say divide by 1/2, but it's still multiplied by 2, and then you get 32 on that one. So 9 on this one, yep, you'd have to multiply it by 1/2 still. 1/2 times the x, and the x in this case is 9. 9 times 1/2, I'm going to write it as a fraction, an easy one, 9/2. And that completes that table. All right, we'll go over these ones together. Right, what have we got on this one? Y equals 3/4 x. So yeah, you're just going to take your x values, multiply it by 3/4, and you're done. So 1 times 3/4, that's not a hard calculation. It's 3/4. Okay? All right, so 16, times 3/4 right there. Bam, that'll give us the answer, and that should be 12 on that. Now again, going in the other direction on these ones, now we're finding the x value instead of the y. Instead of multiplying by 3/4, just divide by it. And yeah, you can type that directly into the calculator. 9 divided by 3/4 would give us a 12 on that one. Okay, so that fills in that table. Now this next one is y equals 10x. And so we're going to take the x value, multiply it by 10, just like the equation tells us to do. Well, 0 times anything is 0. That's fine. And since we're multiplying by 10 on the x values, on the y values, we're going to have to divide by 10. And 10 divided by 10 is 1. Yeah. Now, this next one's going to be pretty big, even though we're still multiplying by 10. It's an easy calculation, though. It's 300 on this one right there. So that completes that table also. So what if the coefficient of x, what if the rate of change is a decimal? No problem, you guys. We can still do those. Again, you're multiplying the x's by 0.1 right there in this case. So 1 times anything is itself, so 0.1 on that. 5 also, just multiply it by 0.1. You can do that in the calculator and give you 0.5. 5 groups of a tenth is 5/10. Well, once again, instead of multiplying by 0.1, in this case we're working backwards. So instead of multiplying by 0.1, we're going to divide it by 0.1 to find the corresponding x value, which in this case is 400. Kind of a big number right there. That's okay. Now this next one's pretty good. It doesn't show what we're multiplying the x by, but it's there. It's always there. It's always watching. It's a phantom 1, you guys. So like if you take a 0 and multiply it by -1, boom, you'll have the y value, which in this case is 0. Same with the 4. 4 times -1 is, -4. Now the next one, -4 times -1 is +4 though, so make sure you understand the difference. Some of you guys would have said, well, the negative on the x just means you're going to change the sign, right? Yeah, that's true unless it's 0 because it doesn't have a sign. So 4, we change the sign from positive to negative. The -4, we change it from negative to positive. It's that easy. So what about writing equations for graphs for proportional relationships? It's so easy. In fact, as long as you can find the rate of change, which on proportions is very easy, then this hopefully is very easy. So let's just remember, in order to find the rate of change, right, we kind of make this little stair step right here. Now it is a rate, and we're going to make it a fraction on this one. I guess with this one it's more of a ratio because there's not any labels, right? But we'd say, well, how far up does it go? It went up 4. Okay, now up and down, that's our numerator, and since it was up 4, it's positive. And then it also went to the right 1. Okay, so right 1, that's a positive 1, but I can simplify this into simply 4. Well, the equation for that then, if I wanted to write it, would be y equals, and then you put your rate of change, which in this case is 4, just multiply it by x. And that's why writing these in this form, writing the equations for these, is just a matter of finding your rate of change. Well, here's something else you guys realized, hopefully you realized anyways, is that the ordered pair, maybe you didn't realize it because we haven't gone over ordered pairs yet, but this ordered pair right here is 1, 4. The x value is 1, the y value is 4. Well, if you make this, and this is only with proportions, you guys, where you just take the y value and divide it by the x value, and you have your rate of change. It would have worked for this one as well, which is at, what is that, 2, 8? Yeah, well, you could have taken 8 divided by 2. It's still 4. Okay? Now, as soon as this line, because we know a proportional graph, it has to be straight, and it has to go through the origin right here in the middle. As soon as it doesn't go through the origin right here, we can't do this with the ordered pairs. So I prefer to look at it with this stair-step kind of thing. So take a minute and see if you can find the rate of change on this one in order to write the equation, all right? 1 minute, go. All right, hopefully you guys got this one. Let's take a closer look in order to help us write the equation. And again, I'd be looking at the rate of changes on these ones, so I want to figure out how far up it goes, and then, in this case, how far to the right between the 2 points that they gave us. Well, before you say it went up, oh, well, it did go up 5, by the way, which is fine. Right, so in our fraction for the rate of change, we know it's up 5, which is positive because it's upwards, but it goes to the right. It doesn't go to the right 5, you guys. It goes to the right 5 lines, but how much does each line represent? Because this gets to 20 right there. So it went, I think it's 1, 2, 3, 4, 5. Yeah, that's 4 each. 4, 8, 12, 16, 20 right there. Well, we don't really care that it's going to the right 4 each line, other than we do know that it's going to the right 20 units. All right, so that's 5 over 20, which does simplify into 1/4. Okay, so even though, and again, this goes back to the whole idea of when you put your graphs out there, it's easy to manipulate people's minds, because this one looks like it's, well, it looks like it's pretty steep, right? But if it was a 1-to-1 ratio in the scaling, this would look really, really flat, okay? So, not that you should mess with people's minds. Sometimes it comes across as dishonest, but if you want to, if you're that kind of person, well, math is the way to do it. So y equals, we got our rate of change is 1/4 x, and that's the equation right there. All right, so let's get the equation for this one. Now, we know it's a ratio, the rate of changes, and we need 2 values that this goes through that we know, and I'm going to use 0, 0 just because it's so easy to use. And then they gave us this one. It's not required that you use that one, though, because you guys see that we could find the exact values at these other points as well. But just be careful, because if you're counting lines, that's fine. You just need to know how much each line represents. So I'm using this triangle, I guess, right here, right? And I do see it goes up, but how far up does it go? Again, you could say, well, it goes up 8 lines. That's true, but each line looks like it represents 1,000. So it went up 8,000. And then it's going to go to the right. Now, each of these lines do represent 1. So it went to the right. Oh, I'm sorry. Each of them represents 1/2. So this one went to the right 8 lines, but again, I can see right here that it represents 4. So it's 8,000 over 4, which does simplify to just a straight 2,000 on that, okay? Well, what does this mean for the equation? Well, it means the equation is still going to be this y equals mx business, but now we know the m, it's that 2,000. That's the rate of change. It's 2,000 y values to every 1 x value. So we'll put that in there then. And there we go. That's the equation. All right, the last one, and then you guys can start on the assignment. This is where we really need the points that we can define. And, of course, the origin's nice. We know it goes through the origin because it's proportional. But in addition, for me, it looks like I'm going to use this one. But, again, just be careful with using the grid lines on this one as 1, because, we can see pretty quickly that this goes up. It's not 2, but it's up 8, even though it's 2 lines. And then how far to the right does this thing go? Well, again, just kind of following that line down, we can see it's 3. So it goes to the right 3, which means our ratio is an 8-to-3 ratio. And that's as far as I can simplify that anyway. So in my equation, y equals mx. I can replace the m pretty quickly with that 8/3 right there. Then this is my equation for that. All right, so there's our objective. Hopefully you guys feel pretty good about writing equations for proportional relationships and even using them to find maybe some missing values. So this is the time that you guys need to grab a computer and get started on the assignment if there's enough time left. If not, keep studying this stuff. And Well, the sub can tell you whether there's enough time left, but hopefully you guys learned and feel pretty good about that objective, because we got, well, actually, I think we got the review next time, you guys, and then after the review is the test. So be prepared, it's coming. If you guys have any further questions, just write them down and then bring them to class next time, and then we'll talk about it, okay? I will see you guys next time.